Hello everyone. Next presentation regarding thermodynamic cycles for CI engines. In early CI engines, the fuel was injected when the piston reached at the higher point and thus combustion lasted well into the expansion stroke. In modern engines, the fuel is injected before 20 degree above. That is uh, the all over graphical presentation shown in both pictures. That is the first is the fuel injection starts in early CI engines and fuel injection starts in modern CI engines. These are two figures. The combustion process in the early CI engines is best approximated by a constant pressure heat addition process, that is the diesel cycle, and the combustion process in the modern CI engines is best approximated by a combination of constant volume and constant pressure, that is called dual cycle. These are both are cycles is very important in CI engines. The introduction regarding the all over operating cycle of an IC engines can be broken down into a sequence of separate processes. In that particular including the intake, compression, combustion, expansion and exhaust. Actual IC engines does not operate on ideal thermodynamic cycle that are operated on open cycle. The accurate analysis of IC engines processes is very complicated. To understand it well, it is advantageous to analyze the performance of an idealized closed cycle. Air standard cycle. Air standard cycle differs from the actual by the following. First one is the gas mixture in the cylinder is treated as air for the entire cycle and property values of air are used in the analysis. The real open cycle is changed into a closed cycle by assuming that the gases being exhausted are fed back into the intake system. And third point is the combustion process is replaced with a heat addition term, that is the Q in of equal energy value. The contents regarding that the open exhaust processes which carries a large amount of enthalpy is denoted by Q out of the equal energy value. And fifth point is actual engine processes are approximated with ideal processes. In that particular, the almost constant pressure intake and exhaust strokes are assumed to be constant pressure, and compression strokes and expansion strokes are approximated by isentropic processes. The combustion processes is idealized by a constant volume process, that is called SI cycle, and a constant pressure processes, that is called CI cycle, or a combination of both CI dual cycle. Exhaust blow down is approximately by a constant volume processes. All processes are considered reversible. Next cycle is, that is the diesel cycle. Means fuel is injected into the combustion chamber very late in the compression stroke due to ignition delay and the finite time required to inject the fuel combustion and lasted into the expansion stroke. This keeps the pressure at peak levels well past TDC, and combustion processes is approximated as constant pressure heat input in an air standard cycle, that is called diesel cycle. The all over process of early CI engine and cycle versus diesel cycle, that is the first row we have to be see, that is the actual cycle, and second row, that is the diesel cycle. In that particular actual cycle, the fuel is in intake stroke, that is the first step. Second step is compression stroke. In that particular, fuel and air is going to be mixtured. Then third step is power stroke, that is a fuel injected at TC, and last point, that is last step, that is the exhaust stroke. In that particular, the combustion products is going to be outer side. So these are the actual cycle. But regarding diesel cycle, the first step is compression processes, second step is constant pressure heat addition processes. Third step is expansion processes, and last step is the constant volume heat rejection processes is available in diesel cycle. So these are the all over cycle number of steps in regarding actual cycle and diesel cycle. Next is the graphical presentation of air standard diesel cycle. The all our process regarding 1 as to 2 is isentropic compression, which is shown in graph. Then the second process is 2 to 3, that is the constant pressure heat addition. Next process is 3 to 4, that is the isentropic expansion. And last process is that is a 4 as to 1, that is the constant volume heat rejection. First law analysis of diesel cycle. Equation for processes 1 as to 2 and 4 as to 1 are the same as those presented for the Otto cycle, and 2 as to 3, that is a constant pressure heat addition. So these are the all over first law analysis for our diesel cycle, and the mathematical and numerical expansions number of equations is going to be available here. Every student must be note that particular equations. Next we have to be most important point, that is the calculation of thermal efficiency. The regarding of that particular thermal efficiency, the formula is available here for the diesel cycle. Please note that also. For cold air standard, the above reduces is also available. Note the term in the square bracket is always larger than 1. So for the same compression ratio R, the diesel cycle has a lower thermal efficiency than the Otto cycle. When RC is equal to V3 divided by V2 is has to 1, the diesel cycle efficiency approaches the efficiency of the Otto cycle. Next graphical presentation is thermal efficiency. The cutoff ratio is not a natural choice for the independent variable. A more suitable parameter is the heat input. The two are related by the following equations, that is the all our calculation purpose. According to above graph, the following calculation is going to be calculated. Diesel cycle. In that particular diesel cycle, the induction stroke is available. The induction stroke in a diesel engine is used to draw a new volume of charged air into the cylinder. As the power generated in an engine is dependent on the quantity of fuel burned during combustion, and that is turn is determined by the volume of air, that is oxygen, present, and most diesel engines use turbochargers to force air into the cylinder during the induction stroke. This is the picture of induction stroke in diesel cycles. The all over fuel is available, which is shown in colored part, and these are both two strokes is going to be available there, that is the induction stroke diesel cycle. Next point is the compression stroke. The compression stroke begins as the inlet valve closes and the piston is driven upwards in the cylinder bore by the momentum of the crankshaft and flywheel. The purpose of the compression stroke in a diesel engine is to raise the temperature of the charged air to the point where fuel injected into the cylinder spontaneously ignites. Next is the compression ignition. Compression ignition takes place where the fuel from the high pressure fuel injector spontaneously ignites in the cylinder. Power stroke. The power stroke begins as the injected fuel spontaneously ignites with the air in the cylinder. As the rapidly burning mixture attempts to expand within the cylinder walls, it generates a high pressure which forces at the piston down the cylinder bore. The linear motion of the piston is converted into rotary motion and through the crankshaft. Next stroke is that is the exhaust stroke. The exhaust stroke is as critical to the smooth and efficient operation of the engine as that of induction. As the name suggests, it's the stroke during which the gases formed during combustion are ejected from the cylinder. This needs to be as complete a process as possible, as any remaining gases displace an equivalent volume of the new charged air and leads to a reduction in the maximum possible power. This picture is exhaust diesel cycle. In that particular diesel cycle, the all of fuel is available at the colored part. A diesel cycle, the ideal cycle for CI engines, and CI power cycle useful in many forms of automotive transportation, railroad engines and ship power plants. Replace the spark plug plus carburetor in SI by fuel injector in CI engines. These are all our pictures is available of gasoline engine and diesel engine. In gasoline engine the spark plug is available, and in diesel engine the fuel injector is going to be available there. Diesel engine model which is to be shown in above slides, that is the number of parts is going to be available in that particular combustion chamber where the air combusts due to a increased pressure. Crankshaft, that is the turns the up and down motion into the rotating motion. Next point is cylinder is hollow and stationary. Next is the piston slides up and down in cylinder. Piston rings provide a tight seal between the piston and cylinder wall, reduce friction and control the lubrication. Fuel air cycle, that is a consideration and assumption. The actual composition of the cylinder gases is the cylinder gases contains the fuel, air, water, vapor, that is the residual